Hello everyone and welcome to my channel. For those of you who don't know me, my name is Bilal and I'm a fourth year MD PhD student at the University of Maryland, currently pursuing my PhD in bioengineering. And on this channel, I try to go over some things that I think are beneficial to people who are applying or interested in MD PhD programs, or just want to learn more about what an MD PhD program is. Now, one of my most popular videos was the one that I released about a year and a half ago, where I talked about the pros and cons of doing computer science as a pre-med. Looking from the comments and feedback that I got from that video, it seems like a lot of people were really interested in seeing or learning more about merging the two, computer science and medicine, together, and how that can be applied on a day-to-day basis. Now in this video, what I want to do is talk about how my computational background has really helped me or benefited me during my MD PhD training, both as a medical student during my preclinical training, as well as during the graduate phase of my training. Without further ado, here are a few ways that it's really helped me during my MD PhD training. The applicability of my computational background was pretty limited during my preclinical years because my main focus was on medical school. However, I was able to do some research, and although it wasn't substantial, I think it was a really good experience that could have gone on longer if I chose to do so. Like, I could have definitely got more involved in, and I think that if you're in a similar, if you do come in with that background, there's definitely a lot of opportunities that you can get involved in as a first or second year medical student, which honestly can be balanced quite well with a preclinical or medical school curriculum. As a first and second year, I shadowed or I volunteered with a deep learning lab that was at my school. I learned a lot about neural networks, especially convolutional neural networks, and how they can be applied to medicine, such as detecting or classifying early markers of Alzheimer's. And so that was a really quick introduction that I had. This is something I did on my own. I reached out and I just found opportunities on campus where I could learn more about this stuff. So that was really it as far as research during my first year, during my preclinical years in medical school. But I think the other way that it came in handy was that I was able to engage in a few side gigs which were beneficial to me financially speaking, and I had a lot of fun doing some of those things. So that is one way that the computational background came in handy as a medical student. Where it's really come into play though has been during my graduate training, and that's for a number of reasons. So number one, it's got to be the lifestyle. I get to do a lot of my work from home, right here in my bedroom. It's great because there are a few days where I don't feel like going into the lab, where I feel it, but I'm still able to get stuff done. It also means that, at least prior to the pandemic, I was able to go out and visit family or go travel a little bit and still get some work done. And one of the biggest benefits of working from home is that you get to hang out with your pets. This cat is actually not my cat. I also do a little side gig where I babysit other people's cats, and I think being a computational, it's really cool because you get to hang out with these guys all day. The only not cool part about it is when you stick your butt out. Like this. Really, to break it down even further, I think the computational background has had a lot of benefits for me as a PhD student. The way my PhD is, the way my research is going right now, it's essentially half and half between my computational work and my lab work. So I do go and spend a lot of time in the lab where I'm running some of the very typical traditional molecular biology techniques that you might be aware of, like Western blots. I do a lot of cell culture. I work with iPSC stem cells. So I do a lot of that type of work. But in addition to that, I also spend a lot of time doing computational work. And that computational work is in the realm of systems biology. So I spend a lot of my time trying to understand how small changes in a cell can affect the metabolic system as a whole. And to do this, I have to do a lot of my work on the computer, and I work with these computational models that allow us to do some very important things. They allow us to understand things that we otherwise are not able to look at experimentally. For example, if I want to look at how the entire metabolism of a cell changes, it's really hard to do that experimentally because there are thousands and thousands of reactions that take place in a cell. But I can build these models on a computer and then carry out specific tests, such as what happens if I inhibit this specific enzyme? What happens if I knock out this specific gene? And I can do all of that work on the computer, and that gives me a framework to understand what might be happening in a real cell. And by creating these predictions computationally, this gives us a lot of different ideas to work with. And those ideas lead to new hypotheses, new ideas that we can then go ahead and test out in the lab. So instead of trying to test out 1,000 things experimentally, we can really narrow that focus down to a subset of the original possibilities and then explore those specifically in the lab through traditional experimental techniques. Now, the other way a computer background comes in handy is the applicability to big data. So I do a lot of work with mass spec data sets, and recently I've been working with RNA-seq data sets. And for those of you who don't know, who haven't worked with this type of data, these data sets can be very, very large, and there's a lot of information in there. By having a computational background, which I've also further advanced in graduate school by taking courses in machine learning, I'm able to understand and figure out what tools are best to use when analyzing my large data sets. It's really easy, and I think this stuff is important. You can go online and you can take, you can do a few coding tutorials and get an idea of how to use some of these packages. They're really easy to deploy, but understanding which one is the most appropriate to use in a specific situation takes a lot more thought. So I think having this background has really situated me to start understanding which tools to use, how to best start analyzing the data. So for example, if I get a really large data set, I do some exploratory data analysis where I try to identify certain patterns. In general though, it's really nice to have this computational background, because then I can use tools like pandas and NumPy and Python to crunch that data. Honestly, I barely use Excel anymore because I think Python is such a powerful tool that I don't really need to use it as much. I'll do it here and there if I want to do something quickly, but in general, I just analyze everything on Python. And to kind of extend that comes in really handy when I am doing a lot of experiments in the lab and I want to analyze my data quickly. So my PI requires us to send in progress reports on a weekly basis, and we meet with her. But by using these computational tools, I can quickly take my data sets, such as data that is acquired from a 96 well plate, which can have a lot of wells. Sometimes the samples are spread out in a way where if you worked on it with an Excel sheet, you have to manually situate the groups together and figure out how to calculate the appropriate averages and standard deviations. But now with Python, what I can do is I can take my data and feed it right into my scripts, and that'll automatically calculate the necessary statistics and also generate plots that I can go ahead and put in my progress report almost immediately. And so for me, that's been a huge time saver, and I think it's been super beneficial for that reason. And a quick side note for those of you who are wondering, the main programming languages that I use are Python, MATLAB, and occasionally R. Python I use for almost all of my data crunching and data analysis. I love pandas and NumPy. I think they're really good tools, and for me personally, they're the easiest ones to work with. They make the most sense, and I think they're very intuitive. MATLAB I use for all my modeling work because a lot of those packages are found on MATLAB. I wasn't initially very fond of MATLAB. I didn't really like it as much as I like Python, but I think it's really good for when you're working with matrices. That's kind of what MATLAB was designed to do. It was designed for a lot of these linear algebra and matrix operations, and once you get the hang of it, it's not bad. I actually do enjoy it now, and there's some things that I prefer doing in MATLAB over Python. So for example, one of my machine learning classes, we were required to create some of these machine learning algorithms from scratch, and I think that's easier to do in MATLAB because the matrices and the finding the syntax to operate on these matrices, it's easier and it's a little bit more intuitive than it was in Python, at least for me. In Python, you kind of have to call everything through NumPy, and you have to look up what to do and how to do it exactly. For me, it's a lot easier to do that in MATLAB. Third language there is R, which I think has a lot more, which I think is more helpful when looking at experiments and trying to calculate statistics for some of these experiments. R also has a lot of really great packages for RNA-seq and transcriptomic analysis. There is the Bioconductor suite of packages, which are really helpful. So there's a whole community of people who have worked on this stuff and who have built these packages in R. And so I think for that reason, it's really helpful to know R as well, in addition to the other two languages that I mentioned. Now, in a more general sense, I think you can really get your hands in you can really get involved in a lot of different projects in the lab, which is kind of what I'm doing at this point. I'm able to set up a lot of collaborations within the lab and also outside of the lab. And hopefully, I'm really hopeful that that will allow me to really boost the amount of publications that I can put out during my PhD years. So, to put it all together, having a computational background has been absolutely fantastic. It's really been beneficial. I've thoroughly enjoyed it, whether it's because I can do a lot of my work from home or because I can get involved in a lot of different projects in the lab and do all sorts of cool things like using these models to come up with new predictions that I can explore experimentally, or crunch and analyze the data that I've collected in the lab through these data analysis pipelines and be able to get my data right there with the click of a button or the click of a mouse. And it's honestly been super helpful. I would recommend it to anyone who is thinking about it. And in general, honestly, during COVID, it's been a super helpful thing to have in my toolbox. One of the projects that I've been working on has been a computational project where I've been looking at an older data set that was generated in the lab. And using some of these techniques, I've really been able to push that forward, and we're hoping to get a paper out of it soon. And so in a way, even though I went a couple months without going in the lab, I was still able to make progress, and hopefully we'll get my first paper out soon. Video. I hope you found it beneficial, and if you have any comments or questions that you'd like me to answer, feel free to leave them in the comments below. I'll try to get to them as soon as possible. And also, if you have any ideas for future videos or any topics that you would like me to cover in a future video, definitely let me know. I'm trying to come out with new videos that I hope are beneficial to you guys. So definitely hit that subscribe button and tune in next time.